Hello everyone, welcome to my YouTube channel where we design structural elements, we model, we analyze, and we also design structural elements. On these tutorials I'll be teaching you how to model this 25 by 12 meter portal frame. We are going to model it, we are going to analyze it, and also design all the structural elements from the columns to the roof rafters to the purlines, and also the stud columns and the pad footings. Okay, if you have not subscribed to my channel, if you're new here, you have not subscribed to the channel, please do well to subscribe. Encourage us by subscribing to the channel, liking the video, and also dropping comments so we can serve you better. Thank you. Let's get right into it. Okay, so we are going to be doing a portal frame. The first thing we are going to do is create a axis. So you come to modeling, we are going to be using orthogonal axis generator. Click on orthogonal axis generator. Then we pick a point where we want to start. Any point you can pick here. So I picked here for as my green intersection where I want to start it. Okay, so you see green intersection. These are the reference point. This is the reference point I picked: x 5000, y 5000. Okay, so my direction 1, I want it 5000 space. That's 5000 times, it's 5000 times 5. Okay, what I want here to be 6000 times 2. Okay, so my axis extension length I want at 2000 millimeters. Can press OK and allow that to generate. Okay, so this is what I generated. Okay, so you see for direction 1 you have 5000 in 5 places. So you have 1 2 3 4 5. Here we have 6000 in 2 places. Okay, that is it. Okay, so the next we are going to be doing is we are going to be creating a column stud. Okay, not column studs. Next we are going to be adding more stories. So you come to stories, you right click on stories. After you left click, right click on it, and you would click on insert stories. Right, so we are going to be inserting 2 stories, one for the column stud and one for the portal structure. Okay, so the story height is about 3000. I'm going to use story height of 3000. Press OK. Okay, these are previous. Do you want to continue? Yes, we want to continue. Yes. Okay, and we have 2 stories created. You can come to stories, left click again, right click on it, and you edit the story. Okay, so for a column stud, you want a column stud height. You can change the height. You want a column stud height to be 450 millimeters. Okay, and we want the height of a steel water frame, the height of it to be 3200. Okay, and so that's it. So we want our foundation depth to be 1100. Click OK, and that's been happening. So you come to story 1 where we have a column stud columns. Okay, so you click on column to insert the stud columns. I'll allow you for the drop down menu for the column to come out. Okay, it's out. So our stud column are going to be using 400 by 400 stud column. Okay, 400 by 400 stud column. You can click here to add a column. The adding columns are the positions we want to add. Okay, so that's it, 400 by 400 columns. So we are adding the corners where we want the columns to be positioned. So you can just add that. Okay, sorry, you can delete that. You don't want it there, you want it here, here, and here. Okay, so you can close it. Okay, so those are the positions we want our columns. To be placed at these positions. All right. So next thing we are going to be doing is we are going to be going to the next story. That's our story 2. Story 2. Okay. We're going to be adding our steel columns. You come to steel members, come to columns. Okay, so we come to our section manager here. Okay, column section manager. We're going to be using from the British Standard Database. So we're going to be using universal column. So we click on the universal column. We are going to pick a 203 by 203 by 52. We are going to be using as a column size steel sections for these tutorials. So whatever, you can decide to pick what you want to pick for your own. So we select that, press OK. Now we'll be adding our columns. Click here to add the column. Click the positions you want to add your columns. Okay, so that's that. You can close this. So you're going to come to our view, right click on the view. You're going to check the 3D physical model so you see what you have done. Right, so this is what we have done. First, we have our column stored, and now we have our steel sections for our columns. Right, okay, so you can come to your view tab. We can, let's put this as style vertical so we can be seeing both the plan view and also the 3D view. So we come back to the plan view. So after this, what we are going to be putting is roof beams. Okay, we're going to be putting our roof beams for the edge of it. So you can come to modeling, come to steel members, beams. Okay, come to our section manager to come to U beam, universal beam. We are going to be using a 152 by 152 by 89 by 16 for this tutorial. So you click OK, click OK. So you are going to be inputting that from here. Drag it to the end. Okay, so do you want to split? Yes, we want to split it at the node. So you click yes to split it at the nodes. Alright, press your escape key. You don't want it again. So here you can do the same thing. Click on the first point, you can click on the second point. You can run it like that, or you can just drag it from the beginning to the end as you would want to add your beams. Okay, so that's it. We have our beams. So see, that's how it's been placed. Right, so the next thing is our roof beams. You can come to our steel members, beams, steel beams again, section manager. Come to U beam. We are going to be using a 254 by 146. Okay, by 43. 254 by 146 by 43 UK beam. Select that. Okay. So next we are going to be doing is we are going to come to the 3D view. Right, come to the 3D view because we want it to be slanting at a certain height. So we're going to do it this for our delta z of I will be 0. For our pitch for our roof, our pitch, we're going to be using a pitch of about 1500. Okay, so we're going to put 1500 there. We're going to start from here and end it here. Okay, you can escape that so you can see what you've done. If you check your 3D view, you see how it's being pitched because of that delta z. Okay, so you can just click on this beam again, right click on it. So we are going to be using that same property. You can click on properties. Okay, so we can click this and this. Okay, escape, click it, this and this, escape, and do it like that till you're done with one side of it. Okay, so you're done with one side of it. Okay, So notice the positions. Notice that it's from left to right. From the left side is I, from the right side is J. So in imputing the next side of it, okay, imputing the next side of it, we're going to change this. In place of this delta Z of the I, you're going to put in 1500, and the Z will be 0. All right, so we can click here, the I and the Z. Okay, so if you look at your 3D view, you're going to see what we have just done here. All right, so you press escape and you do the same for this other side. Okay, escape that, and this is what we have. This is what we have been able to do. Okay, so next thing after adding our roof beams, okay, our roof rafters, next we are going to be doing is we are going to be bracing a structural element, a porta frame. For extra stability, we need to brace, so we come to our steel members, come to bracing. Okay, click on bracing. So when you want to click on bracing, we are going to be using the 3D view. When you click on bracing, you're going to click 2 points. Okay, you can come down and select that again, select brace. So we are going to pick 2 members we want to brace. So we want to brace this column and this column. So you click both of it. You click the first one and you click the second one. I give it time for it to load the brace window, so you can decide the particular steel section. Okay, it's up. So you see the profile, they're using a UK angle section of 90, default of 90. Okay, let's give the view to load. Few moments. Okay, that's up. So our profile, you can change that to whatever profile you want to pick. So we are going to be using the universal angle. Okay, so the smallest on Prota is 90 by 90 by 8. Okay, so that will select that. Okay, so what brace type are we using? We are using an X brace, that's why it's X. You notice X brace. So we can check to see different types of bracing. There's a V, there's a K. Okay, but we are going to be using the X type of bracing. Okay, so you can just check that to be sure of how it's going to be like. So you can click OK. Once you click OK, it has been braced. So that brace command is still on, so you don't need to press escape. You can just keep on continuing it. Click another column you want to brace, click another place you want to brace, so it pops this up again. The same settings you used for the previous one will still be functional here. So you can just check and make sure it's okay. Click OK. Same thing, you click and you click, press OK. So you're going to rotate this, so we can do the same for the other side. Okay, click the first and the second member I want to brace. Okay, okay. After bracing the columns, you're also going to brace the roof rafters and the roof. We are going to brace on them also, so you can just click 2 roof you want to brace. Okay, all right, turn it, rotate it to the other side also, and do the same thing. So that's what we have. You can press escape now so you can leave the brace command. You can press escape. Okay, and this is it. You have added our columns, we've added our roof beams, and now we have braced. After bracing, you want to add roof purlines. So you can come to your steel member here again, click on your purline. When you click on purline, you're going to pick the first point you want to add your purline to the last point. So this is the first point you want to add a purline. This is the second point, the last point. Okay, you click both of it, almost like the same way you created Breezy. It's the same way we are going to be creating our polines. Okay, so this is the geometry, this is the view, this is how it looks like. You can zoom in to see how it looks like. Okay, so this section is using a UKC section, right? 100 by 50 by 10. So we can use that as a, can decide to pick whatever. I can decide to use a hollow section or a Z poline section, so you can just check that out. And well, for this we are going to be using a UKPFC, a channel section, a universal channel section of 100 by 50 by 10. So section alignment is on the section, and the layout is the default. So this is about 1000. So if we look at this down here, I want a little projection at the end of my roof rafter. I want a little projection. So RE and LE. So for RE, it's left cantilever length, I'm going to use 600. Okay, so RE2, I want to use 600. Okay, so D, this D is a distance, because if you notice, it's separated. You zoom into it, you realize that the poline is separated. It's not a continuous poline. It stops from one roof rafter to the next. It's divided. Okay, so if you want it to show, you can actually eat, but we don't want to show. We just want it to be connected this way, close together. So that's it. You can leave that. And also, I don't want to have a staggered rod, so I can come to sag rods. These are my sag rods. I don't want it to stagger. Okay, so it says stagger offset is 100. So if you zoom in, you understand these are the sag rods. It's staggered. I don't want it to be staggered, so we can change this to 0. Press enter. See, it aligns. It's now straight. It's no more staggered. Okay, and that is it. We can leave that to be, and click OK. Okay, and our polines have been added. Same thing, you can just rotate this, do the same thing, click the first one and the second one, and automatically it uses the same settings we used at the previous one on this new one. Okay, well, you can just go through it to make sure. See, LE 600 we used, the RE also the 600 we used. Okay, check the sag rods and notice it's 0, the stagger offset is 0, so it uses the same settings we used for the previous one for this new one. So click OK. You can now click your escape. Okay, so you look at your 3D view. You can expand this, come to views, come to reset. Let's reset the windows, and you have your 3D view, so you can zoom into this and you can appreciate what you've done. As a reminder, if you have not subscribed to my channel, you can subscribe to my channel for more design tutorials. Like the video, and please, you can drop your comments on any video you want us to do. Okay, so this is what we have been able to do for now. Okay, so we can come back to our view, come back to our tile vertical. Okay, so the next thing we are going to be doing is we are going to be adding cladding. We're going to be cladding our members. So okay, let's leave this out. Let's reset our views. Let's just use the 3D view. Okay, so next thing we are going to do is we are going to add cladding, because it's from the cladding we are going to be able to load our portal structure. Understand? To load it from the top. Okay, so we can just come to our modeling, come to steel members, come to cladding. So you click on cladding. When you click on cladding, you're going to click on the poline to added. Give it time. Okay, so once this comes up, you can just click OK. Okay, cladding has been added. Do the same command. You don't need to press escape. The cladding command is still on, so you click on the second part and you click OK. Okay, so that's it. You can press your escape key now. So this is our portal frame structure. Okay, so the next thing after that is we are going to be loading. We are going to load our portal frame. We're going to load. So you can click on the cladding, right? Right click on it. You can see right click. You're going to see edit loads. Okay, so you just click on edit loads. So we haven't defined load cases. So would you like to define your load case now? You can just, let's define our load cases at once. So we said yes. So So you're going to be using a loading generator. Instead of adding, you just use the loading generator. You click on the loading generator. It's going to automatically generate load cases based on Eurocode 2. Okay, because we are designing to Eurocode 2, so these are the combinations. And okay, so we click OK. Okay, so it has defined that lots of load cases. So you can click on OK, and a load cases has been. So once that is done, you're going to just give it time for it to load up our load window. So this is it, right? So you can click on for the top to get the plan view. Okay, so what next we are going to do is the load we are going to use is a full uniform load. So you can just click on the full uniform load. Okay, once you click on the full uniform load, you see G is for dead load. Okay, if you increase this, Q is for live load. So we are going to start with dead load. Load properties, dead load. Direction is gravity. It's coming from the top, on top of the cladding. So the magnitude we are going to be using for dead load is going to be 0.2. Magnitude 0.2. So what you do is you just click on each panel. Once you hover your mouse over it, you see it's going to be showing. So you just click on it to add. Once you click on it, it changes color to purple, means that's added. See, G1, the magnitude is 0.2. Okay, so we can just do that and add for each panel. Okay. So that's that for the dead load. So we can just change this to live load. We're going to be using magnitude, same magnitude of 0.20 for a magnitude for our live load. Okay, so we can just add that too. Same way we added for the dead load, just click the panels. Once you click, you see now it has changed from G to Q. Okay. So we have added dead load and live load for one side of our cladding, so you can click OK. Okay, so we have added it for cladding 1. It's cladding 1, so you can just come to the second one, click on cladding 2, same thing, right click on it, we edit loads. Same way we did for the other side, we do the same for this other side of it, right? So full uniform load, gravity 0.2, and click on make it plan view, so from top, and you add. As well for dead load, you just change this to live load, same magnitude, and we add. Sorry, just click that again. Okay, so that's dead load. Okay, that's live load. Okay, you've added, so you can just check, make sure you check this. So you come to G. Okay, there's dead load G, include live load. Okay, so you can just click OK. So we are done adding loads. So next thing you're going to do, just make sure you save your work. Ctrl S to save your work. All right, so that is that. So we can come to so we're going to have to check our model. So you come to review, check your building model, check. When you check model, so we start, check our model. Okay, so our building model check is complete, number of errors 0, so our modeling is correct. You can close this, you come to analysis because we need to analyze. Okay, so you come to building analysis. No need for load decomposition since there are no slabs to decompose loads from slabs to beams and from beams to columns, so no need to decompose. Okay, so we can now edit materials. So what concrete are we using for our columns? What concrete grade are we using for our columns? Okay, so we are going to be using a C20 by 25. Apply to all members of this class. What we're going to be, so we just, concrete type is a normal weight concrete, so unit weight of concrete here is 24. Okay, so this is, once you pick it, it's automatically set based on Euro code standard. So click on OK. We are going to be having columns here. There are no concrete beams, so there's no need to be checking most of this. So we can come to our grade, steel grade for the columns. We're going to be using the 410. So can apply this to all members. So the diameter, I come to rebar diameter, edit it. Okay, so for columns, the first one, if you hover around this for columns, we are going to be using Y12 for the columns, Y12 over Y16. So we just click Y12 over Y16. Okay, so we don't have any wall, we don't have beams, we don't have slabs, we don't have rib slabs, or there's a found footing. So we're going to use a pad footing. So for our footing, we are going to be using Y12 also at Y16. So we just click on Y12 over Y16 and untick the rest. This is for links. All links are using, we are going to be using Y8. So we can click on Y8. Yeah, Y8 and Y10 for our links. Okay, we can untick the rest, and that is that. So we can click OK and click OK. We are done setting. So for our steel column, the grade is going to be S275, steel beam S275, and all of this set. So you can come to foundation floor, check the foundation floor for going to be using 2025. Apply to all members here, click on OK. See the grade type is 410, it's already set, and links and all of that. So we can click on OK. Okay, so we can come to the analysis. We have already done our building model check, is ticked correct here. So next thing, X here is for our building analysis. So click on building analysis. Okay, so what are we going to be analyzing? We're going to be analyzing for column reinforcement. So if the column reinforcement that is provided is not enough, it should reselect the bars. I'm going to be doing that steel member check design, so you can do building analysis. Okay, so select all bars, it's doing a design. So our building analysis is complete successfully. Okay, so see, direction 1, relative storage drift satisfies the limit, which is the limit has to be, so it satisfies the limit for direction 1 and direction 2. So we braced our member properly and doesn't sway much, so the limit is okay. So we can click on OK. That's successful. Okay, so you can come to our post analysis if you want to check for your columns. So you can come to post analysis, check column and wall design. Okay, so you realize that our stored column passes. Okay, provided. Okay, so we can come to interactive design to see the section of what he provided. So the interaction design for 1C2, 1C1. Okay, so this is the detail. This is what it looks like. Okay, so provided 1, 2, 3, 4, 5, 6, 7, 8. Provided 8Y12. Okay, and for the main bars and the links, so you can just come to the interactive design here, click on the interactive design so you can see it properly. So this is what I provided 8Y12 critical loading. The critical loading used was 6 of the loading combination and provided this. So if you want your design report, you can just check here for you to print your design report. So you click OK. You go OK. So all our stored column passes. So you can end this, also end this. Okay, so the next thing we are going to be checking, just come to design here. Next thing we are going to be checking is check if our column and bracing and everything pass. So you can click on our columns to check design, click on columns to check if our columns passed. Okay, so all our columns passed. Okay, so it's the UI ratio is 0.3, which is less than 1. So design status is passed. All of it pass. Okay, so you can just click on one and just check selected, so you can really understand it. So you see UI ratio, the axial compression check also passes, the shear check passes for shear too. Okay, so this is it. You can check if you want your design report, you can click here to design check your result. So you just click OK. You close this. Next we are going to do is we are going to check our beams. So you click on beams. Okay, so all our beams passed. Okay, the edge beams and the roof rafters passed successfully. Okay, so you see a slenderness which is 57, which is less than 200 allowable. Deflection check, there's 14.5, which is less than 34.4. Okay, so it passes. Okay, so you can just click on one to check. You can just click on one, check selected. So you're going to show you can just look through it, so you can know what to change and everything, but it passes, which is very okay. So we click on OK. You can close this. You can also check for bracing. Okay, and bracing also passes. So UI ratio is less, it passes, but just the slenderness. Okay, this can be neglected depending, because just for the bracing, it's not really a structure, it's just to brace our members. So you can just close this. All right, so you can just come to our drawings, not drawings, you come to review, come to visual interrogation. You can just check our design status. You can just click on this. Okay, so if it's okay to be green, so you notice all our members, so you just rotate this. Notice all our members are green. That means everything we have done passes. Okay, please don't forget to like the video and subscribe to the channel. All right, so that's that. Next we are going to come back to our plan. We are done with modeling the Prota frame. Next we are going to do is we are going to come to our story 0, so we can add our part bases. Our part base. So we'll come to our story 0. Okay, so you can just click to add. You can just click on one of the columns, right click on it, insert part footing. Give it time to load. Okay, so it's providing a 16 by 2200 with a depth of 400, so you can reduce the depth to about 300. Let's see if it still passes. Okay, the minimum is so we want the square footing. Okay, so what we can do is we can just, this is not what I want, this is too big, this is not what I want. So what we can do is we can just cancel this, come to settings, certain settings I want to do on my pad footing. I don't want that's too big. So I come to settings. Okay, so I come to my foundations. Okay, for my foundations, the allowable stress I want to use for my foundation is going to be, allowable stress is going to be 180. Okay, this is lean concrete, this is the blinding thickness, and the strip footing cantilever length. Okay, so at default, I want a default to be square, I don't want rectangular. Default is going to be square. So pad minimum steel ratio, this is so minimum pad base depth, I want a minimum pad base depth to be 300. Okay, it's a portal frame, I'm not sure it's carrying a lot of load. So I don't want top bars. So minimum steel bar size should be 12. So distribution bars too should be 12. I don't want to use Y16, I want to use Y12. So I don't want top bars. Okay, so show plan. Okay, and that, so this is just general, it's just pad. I'm not, if you want pile, if it was designed for pile, I would have done some settings there, but I don't want anything for pile. Okay, so maximum steel bar spacing, so this is the maximum steel bar spacing I want, 250. Okay, so we can just click OK for that and just allow it, so we can use that setting. Okay, so I'm going to use that setting, so you can click on this. Okay, right click on it and insert pad footing, allow it to design your pad for you. Okay, so it's saying that 17 by 2000, that's what passes. Or I can as well highlight all of this. Okay, I can as well highlight all of this. You just right click on it and insert pad footing. Just give it time for it to, okay, so it's going to design all the pads. Okay, so I want it to do design all. Okay, so this is what it has provided, all of it, the depth of 300, and this is what it's providing. So you can click on OK, and we're going to be using that as a pad base. Okay, so this is what it's providing for a pad base for us. Okay, so you can come to a 3D view to view that. So this is it, a portal frame structure with a pad. So everything is green, that means our design is very okay, very okay. Thanks for watching. Please do well to subscribe to the channel, like the video for more. Thank you.